It's my great pleasure to give this presentation to you. And I also thank for the QCware and Qunasys for giving this occasion. ちょっとここから日本語でやらさせていただきます。
Switching over to translation, so let me introduce myself. Mr. Ide of Aishin. From my part, I'd like to talk under the topic of derivation of optimum delivery route in logistics by using quantum computer. So broadly speaking, I'm going to cover 4 topics. First of all, background, the reason why Anshin is involved in the development of Aishin, and the initiative of quantum computing in Aishin. Thirdly, specific example of vehicle routing problem, especially the truck routing in between work sites, the factories. Together with Dr. Shulman Weinberg, QCware, we have collaborated the optimization. So I'd like to share with you the optimization case stories. And then I would like to conclude why quantum computing for Aishin. There are 2 major reasons for that. The first reason why we should engage with the quantum computing is that we need to respond quickly to the diversifying market needs. And secondly, we have to contribute to the realization of carbon neutral society. Just speaking, those messages may not make sense, but let me share with you the range of business we are in at Aishin, what we are engaged today, and future range of products that we would like to develop. And high efficiency, low fuel, the consumption, that is the area of the car components Aishin produce, automatic transmission, hybrid e-axle for the electric vehicles, components for electric vehicles. So those are the powertrain components, safety and security, comfortability of driving, to driver assist, advanced drive assist products such as car navigation systems. So the Google Map is emerging, and therefore the market for the car navigation is getting intensively competitive, and power sliding doors and logistics support service, energy management, fuel cells for household utilization. So we provide diverse products. But these products alone, you may feel this is a kind of old-fashioned manufacturing industry. That may be the impression: connected, autonomous, electric, shared electric. So those are the norms of the industry. So for this case, what we are going to contribute from the powertrain evolving to the power management. So the power management encompasses the entire vehicle system, safe, security, and comfort, that is driver assist, to be replaced or to be evolved to the driving monitoring system to enable everybody to be able to drive their cars with safety and comfort. And finally, carbon neutrality to be achieved. There are diverse possibilities. So how we are going to cope with those diverse possibilities? So we have to improve the efficiency of production, and we have to reduce the development turnaround time. Efficiency of the production, since we are engaged in diverse range of products, how quickly we can provide and supply those products to the customers. Shorter turnaround time, we design and produce diverse range of products, and this will be the competitive edge where we can differentiate ourselves against the others. Efficiency, maximization of production, and shortening turnaround time of development, how this is to be achieved. In order to achieve these, quantum computing will be the method to achieve those requirements. What we are going to achieve through the quantum computing, we heard a lot in yesterday's presentation: optimization, machine learning, simulation, and Monte Carlo method. And at Aishin, we are focusing upon optimization and machine learning in developing the possibilities surrounding quantum computing. So let me share with you the initiatives that is being pursued by Aishin with the quantum computing. We are 3 areas of activities. 2 of them are application or actual algorithm development, and the final one is slightly different. First of all, application development for the quantum computing. What is the most effective application? We have not identified yet. But if you do not do anything, we don't appreciate the value. So we are focusing upon logistics to possibly apply the quantum computing as the potential application, and exploration of quantum computer hardware for specific applications such as the material development, logistics. There are various needs and image diagnosis. Those technologies that are applied in production areas. So what are the most suitable hardware for the quantum computing? Gated systems, as I have illustrated here, superconducting, trapped ion, photonics, the neutron atom, the quantum dot. Those are the modalities that appears to be available. And what is the most suitable? The sets of hardware that is suitable for the needs, whether this is gated or annealing, what hardware is most suitable, and we are exploring. Finally, the third topic is slightly different from the first and second one. As Aishin Group, we have photonics technologies, the optical the technologies, that is micro-optical comb. At higher frequency, it looks as if it's a set of combs. So the micro-optical comb to be applied to the quantum computer hardware. So we are considering the possibility of applying the micro-optical comb to eventually for quantum computer hardware. Optical technology that is held by the Aishin Group, integration optics, phase control, noise suppression, signal modulation. Those are the areas of the ion trap and optics, and the optics are utilized in quantum computing. So maybe some of our Aishin's own technology could possibly be applied to quantum computing, and we have begun the exploration. Recently, there has been the news release. We've begun collaboration with QCware back in 2020. So the collaboration is released on the website of Aishin, and I'd like to share with you logistics innovation that is beneficial for people as well as to the earth, to the environment. And this is the possible area of application of quantum computing. So please refer to Aishin's website. More detailed information is available for the application of logistics and other areas where the quantum computing may be applied. And a third area, the actual example of the vehicle routing problem. This is the truck routing optimization. This is more complex than the route sales issues. This is even more complex than the route sales. So at Aishin, this is what is going on with the logistics. So we have to digital transformation of the logistics that is friendly to the earth as well as friendly to people. So what we'd like to achieve is innovation in logistics. carbon neutrality, CO2 reduction, those are the requirements. And the technologies should provide a working environment that is friendly to the workers, to the operators, to the drivers. There are 4 elements, and I would like to focus upon the visualization and route optimization of truck logistics. So this diagram indicates the truck logistics at Aishin. From supplier, the material parts are supplied to logistics center, from logistics center to the factories, and from factories to domestic customers. And there's the logistics centers for the overseas customers. And we do also have warehouses at the port site, and we will ship parts and components for the overseas customers. So this is the route for the overseas customers. So in between the logistics center and the factories, optimization route in between logistics centers and manufacturing site. So this is the area I'd like to specifically focus in today's presentation. How we are going to achieve this? This is the quantum computing application roadmap at Aishin. Short-term, mid-term, and long-term strategies. Today, near-term, as of today, we are dependent upon expert knowledge and insight. So the knowledge and insight determines the route for the logistics. And we are also employing the classical computers for the optimization. But the combination of classic computers and experts cannot improve the efficiency of the production and logistics. So what we are doing is that currently available, the NISC, the noise computers with the noises, we try to solve the problem in truck route optimization. In case future, the fault-tolerant quantum computing is available, then we would like to expand the application to the entire supply chain management, if and when fault-tolerant quantum is available. So what I'm going to talk about from now on is that the real-life data, this real-world data of the truck route optimization that we have done. So this is the automatic transmission, manual transmission, hybrid electric vehicles, truck, the logistics routes of the automotive components. We have about 200 suppliers. From those 200 suppliers, the trucks deliver from the suppliers directly to the warehouses, some of them. So the suppliers manage their own fleet of trucks. So we have no control over the suppliers' trucks. But Aishin Group has its own distribution center and the warehouses and factories. So the fleet management of trucks under our control to optimize the management, and we also would like to minimize the number of vehicles in the fleet. 16,000 components, 3,800 tons of the parts and components operating daily, so 20 to 22 days per month. So this is massive amount and volume of components are being transported to the logistics systems. Sometimes the trucks carry parts and components in between trucks. 10 to the 22nd power. So this is the combination optimization solution that requires some massive computing. That's the reason why we're interested in the quantum computing. The data that is required, the number of parts and delivery parts and the information, destination, the start, origin of the logistics, and the hauling time of the trucks, and the truck information, fleet information, driving time, the capacity, the loading, unloading operation, what is the duration of loading, unloading, and we have to optimize the logistics route. And there are constraints that certain trucks will have to go through a certain warehouse before arriving at the destination or the warehouse. This is the outcome. Left-hand side is the expert-dependent, human brain-dependent, the logistics route. It takes 1.5 months to arrive at this, the routing. Annealing, the quantum annealing methodology on the right-hand side. 1.8 seconds was sufficient for annealing computer quantum annealing to arrive at the destination. There is a destination, the distribution center, Nishi or Higashi. This is a gigantic center, so the expert preferred to accumulate the cargo at the warehouse or the distribution center in the center. Quantum computing. Tahara is the assembly factory of the powertrain. Without going through the logistics center, the quantum computing assume that it's better to directly deliver to Hara factory. The operators tend to go through the logistics center, but the quantum annealing arrive at the conclusion that avoiding, in certain cases, logistics center. So what is the sequence of the visiting quantum computing arrive at this optimum routing? So this is calculated by the classic computer. How many boxes were loaded, unloaded at a certain given time? There are 76 trucks under the control. And how many hours of the working time for each truck? And what is the weight of the truck compared to the capacity? And the remaining cargo of the is to be added to the truck at the end of the journey. Here is the summary. The outcome of the annealing, we are tackling with the gated quantum computing. So to what area we should be able to apply the optical or the technology. So that is the area we are pursuing right now. Thank you very much. That concludes our